if I made that, say I went times both sides by 2, I got 2 sine x equals 1. Yeah? If I want to make it equal 0, what have I got now? 2 sine x minus 1 equals 0. You know how to solve that? You'd change it back into that form and you'd solve the thing. Take this one, I times both sides by 2. I got 2 sine x equals root 3. And then I've got 2 sine x minus root 3 equals 0. And I've got these two things that say equals 0. What do you remember about when I'm always nagging to you about equals off times 1? We want things to be equal 0. Now, the reason we want the equal 0 is to solve and often to factorise. So if I said to you, I'm going to take that bit there and that bit there and put them into one question. So I'm doing everything in reverse. So what do we normally do? I give you this, you split it into those, and you solve those questions. So what you're going to do for the moment, I'm just going to rub that off. I'm getting an eraser that works. Okay. So that was background. I often call it a preamble, but I've not said preamble for a long time. Preamble sort of just give you a bit of information. You know where I'm going? Anyone know where I'm going? If I expand that out, what do I get? That times that is 4 sine squared x. That times that, slow down, is 4 sine squared x. What am I forming, by the way? It's hard to say it's a parabola, because it's not just a parabola, it's a quadratic equation. What's that times that? 2 minus 2 times root 3 sine of x. You okay? What's this one times that one? Minus 2 sine x. What's that one times that one? Plus root 3x. Plus root 3, I mean, equals 0. Oh, I made too yucky one. I just about need to start over again. So if I said to you solve that equation, it's about as revolting as we can possibly do. So I'm going to go root 3 plus 2 sine x plus root 3 equals 0. Why don't we do it? Because I've never seen one like that ever. Is that going to go too hard? Because that's minus 2 root 3 sine x, which is that one. That's minus 2 sine x, which is that one. So let's say you walked into a test and it said solve, what have we got? 4 sine squared x minus 2 root 2, 3 plus 2 sine x plus root 3 equals 0. Oh my goodness, I've gone crazy, but actually in some ways I like it. How do I solve it? I want to go back to the original 2 equations I made up. How do I go back to the original 2 equations I made up? This is revolting. I actually write it there. Revolting. And Brandon, you'll know when I make up revolting questions and then I change it. Why don't we do this? Why don't we do that? And it's not so revolting. So what made it revolting? Using a root 3. How do I factorise that? How do I factorise that? I know it's got a squared. So because of the squared, I'm expecting to have 2 brackets. Now, forget about all this. Like, cover it over and say it's irrelevant. How can I get something times something to equal root 3? What times, oh, I'll come over there too far. What times what equals root 3? You can get 1 times root 3. You could also get root 3 by 1. So by the way, what does that sign tell us? They're the same sign and they're both negative. So I know they're both negative. I know it has to have a 1 and a root 3. Well, we hope it has a 1 and a root 3. Although I made a mistake or they made a question that you can't do without other methods. How can we get sine squared? So what is sine x times sine x, just to make sure? Sine squared x. So how can we get a sine squared x? Sine and a sine. Now I've forgotten something on purpose. What have I forgotten? I've also got a 4. So, what times what can equal 4? I'm being really dumb, because in the middle of something that looks revolting, you forget how to do the simple. Which I saw. So I can go 1 times 4, I can go 4 times 1, and I can go 2 times 2. One of those 3 possibilities gives us the correct answer. So let's do that one first. 1 and 4. Let's go back to what we did. Sine and a sine gives us sine squared. Yucky, revolting, take no notice. 1 and a root 3 gives us a root 3. 2 negatives make a positive. And we want the 4, so I'm going to try 1 and a 4. How do I find out which one's the correct one? That one, or that one? By the way, when we made the question up, it was that one. Do we want to just do that one first and forget about the others? Just so we know which one's true. I don't want to muck around with that and that. I'm just going to go that one there. 2 and a 2. Let's expand it out. Eyebrows. Come back to me, some of you are drifting. 2 sine by 2 sine is 4 sine squared x. That one by that one is 2 times root 3. 2 root 3 sine x. Yeah. What's that one by that one?
-2 sine x.
-2 sine x. What's that one times that one?
Oh.
You say it for me. Plus root 3 equals 0. So we ended up with a root 3 just like we wanted. And we ended up with a 4 sine. Can you see that that is that? Do I need to explain that more? -2 root 3 sine x, -2 root 3 sine x, -2, -2 sine x. So what did they do all that for? To be able to find out what goes in the brackets. So, what made it more revolting? If I didn't have a 2 root 3, if I had like a 2 plus a 2 or a 1 plus a 2 would be nowhere near as revolting. So if we walk into a test and we make a question up, can I make up an easier one? Or you walk into a test and I say solve that. So what did we end up with? 2 sine x minus 1, 2 sine x minus root 3. You okay that we ended up with that? What do I do with those two answers? 2 sine x minus 1 equals 0, or 2 sine x minus root 3 equals 0. So, if I gave you that, is there any doubt in your mind what to do? If I said we want the answers between 0 and 2 pi. Is it harder because it's 2 pi? So some people it is because they're not confident with it yet. That's the light you went, no? I watched someone on video talking about we're big boys and girls now, so we use radians because radians is what the real world uses everywhere. So then you go ahead and solve that equation. So you can go work out how to solve those. How do we solve that? 2 sine x equals 1 sine x equals let's go to the short version. I call it all stations are central. Sine is positive, so it can't be there, it can't be there. We're talking about radians. Sine of what is a half? 30. Do you know it automatically without thinking? So what do you do if you don't know that? You do a 30, you go 1, 2, root 3, and that becomes 60. What fraction is out of 180? A sixth. What fraction is out of 180? A third. So, sine of what will give us a half? Sine of pi on 6. So one answer there is pi on 6 there. What's the other answer?
2
pi on 6 there. So, by the way, what angle is that? Who sees 5 pi and 6? If you go 2 pi and 3, people do all sorts of weird things to do all that sort of stuff. So my brain will go this 1, 6, 2, 6, 3, 6, 4, 6, 5, 6. What do I even think that anymore? Because if that's pi, I'm going to go back pi on 6. I still don't think that I think that. I just think oh, that's 5, 6. Because what's this? It's 6 pi on 6. 6 on 6 is? 1 pi. So I just think 6. So what's the next answer? 5 pi and 6. Now this one, can you do it in your head? Root 3 on 2. Let's not do it though. Root 3, not 2 on 2, sine x is root 3 on 2. Also I'm laughing at myself because this is not the greatest video, because I made that revolting bit there. I'll decide whether I keep it or not. I'll have to chop that out later. That's the answers for root 3 on 2. Go back to here, sine of pi on 3. Is it sine of pi on 3? Here's root 3 on 2. What's our first answer? Pi on 3. So go back to all stations of central again, or cast. You guys all go cast, don't you?
Yeah.
So pi on 3 up there, pi on 3 up there. Do you even think about crossing them off? Don't you know what you're doing? You're just going an answer there and an answer there. You missed all of this, didn't you? Yeah. So it can't be this. There's a whole heap in there that you're not connected with, but I'll give it a go later. So that's pi on 3. What's this one? 1/3, 2/3, 3/3. So instead of pi, I've got 3/3 of pi. Your brain start to connect, but that's just 3/3. Whereas over here it was 6. 6. So what's my answers? There they are, there and there.